next example that we will look into is to transfer the content of register R0 to R1. So, this is a simple thing that we need to do, but we have to say in how many ways we can do this thing. What are the different assembly language programming techniques in 8051 that can be utilized for doing this simple operation, that is transferring the content of register R0 to register R1. Now, if we want to do this, then the first method is to have the move instruction directly, say move R1 comma R0. So, this will move the content of R0 into the R1 register. So, this is one possible technique of specifying. The second possible way of specifying this may be we can write like say move 1 comma R0. So, this will do the same thing like when we are telling like 1. So, this is taken as the direct memory address, and as a result the R1 register will get R0. The third possible way of doing it may be just the opposite, that is move R1. So, this is register, but this is a memory location. So, here also same thing, R1 gets the content of RAM location 0, which is basically the R0 register. Then another way of doing it is when we specify both the registers as memory operands, like we simply write like move 1 comma 0. So, when you say move 1 comma 0, so that is 1 is memory 1 will get the content of memory 0, which is essentially, so memory 1 is nothing but R1, memory 0 is nothing but R0. So, the same operation is done. Another way you can write it is slightly tricky. We do it like this, move R1 comma the immediate value 1, the hash 1, the immediate 1, and then we say move @ R1 comma 0. So, what we are doing? So, we are so first in R1 this statement we will put R1, make R1 equal to 1, and in this statement it will be moving the content of this memory location 0 to the memory location pointed to by R1. So, memory location pointed to by R1. So, that will get the content of memory location 0. So, effectively the R1 register will get the value of R0. So, out of all these instructions, you see that this one is definite in the sense that this is modified, this is irrespective of memory banks. So, this one is irrespective of memory banks. So, it will move it from it will operate on the bank 0 irrespective of bank selection. So, it will be operating on the bank 0 registers. On the other hand, other instructions that we have, so they will depend on the bank selection. So, if they are actually all the other instructions, so they will be talking about moving with respect to the current bank. So, they will always access the current bank registers. So, this way if you are willing to access say registers of a particular bank, so you can change the address and use this particular mode. Okay. So, if you are looking for a any arbitrary bank register movement, so you should use this instruction, otherwise you can have many other options. Next, we will look into another program, which is to write a code fragment to save the carry flag in it will save the carry flag in bit location 4, auxiliary carry in bit location 10 and parity in bit location 22 hex. So, this 4, 10 and this 22 hex, so these are all in the bit addressable memory. So, it is these are actually the bit numbers. Okay. So, you remember that we talked about this bit addressable memory, and then there the every bit has got an address. So, we are trying to save the carry flag, auxiliary carry flag and parity flag at 3 different locations. So, how to do that is like this. So, first we clear those locations. First we say clear 04 hex. So, this will clear the bit 04. We also clear the bit 10 hex. So, that 10 location is also cleared, and clear 22 hex. So, that will also clear the third bit that we have in our question. Now, we will check the individual bits like carry, auxiliary carry and parity, and accordingly set the bits. So, for the carry part we can write like this, say jump on not bit PSW dot 7 comma L1. So, if this bit is not set, so PSW dot 7 this corresponds to the carry bit. So, if you look into this bit addressable memory, then this PSW dot 7 is the carry bit. Then if it is not 0, in that case we need to set this location, this 04 location should be set. So, then we will be doing like set bit 04 hex. So, it will be setting the bit at bit address 04 hex. Otherwise, we will come to the level L1, and where we need to check whether the same thing with the auxiliary carry. So, we can do the next check like JNB PSW dot 6 comma L2, and if it is, if the auxiliary carry bit is set, in that case we need to set bit location 10. So, we write like set bit 10 hex, okay. And then in L2 we do the last check where it is JNB, that is the parity bit. So, that is by JNB PSW dot 0 comma L3, and if it is not set, in that case I have to say, if it is, if the bit is 1, if that PSW 0 bit is 1, in that case I have to set the bit 22. So, this is that set B 22 hex, and this is our L3. So, from this point it will continue. So, this is, so this way we can write a program fragment for checking and setting the individual bits, like so getting it is doing the copy of those bits to the corresponding location. So, it is checking the bit, and if the bit is 1, then it is setting the bit to if the carry bit is 1, then the corresponding memory location that is mentioned in the problem, that is set to 1. So, this way we can do this thing. Next, we will look into another program. So, this program is slightly complex. So, here what we try to do is that it says it is a string manipulation program, and there are two strings stored one after another starting from external memory location 6000 hex, and each string is terminated by a null character, that is a 0 byte. Then we have to write to separate subprograms for doing this thing. One subprogram we will do string comparison. So, suppose the names of the strings are say S1, names of the strings are say S1 and S2. So, if it is so if the S1 string and S2 string, so it will be compared. So, it will just compare whether the strings are same or not, same, not same. So, it is just doing this type of comparison. It is not that it is finding greater than, less than relationship. It just checks for the equality, the strings are exactly same and the strings are different. So, if the strings are different, in that case it will put some value into some register mentioning that this the program should do this thing. The main program should collect the results and the comparison collect the result, comparison result in R0, length of string first string in R1 and length of second string in R2 of the default register bank. So, what it says is that this comparison result should be in R0. So, if the strings are same, then maybe the answer will be yes, and if the strings are not same, answer will be no. So, it can be identified by putting a 1 or 0 in the R0 register. Then for the length of the strings, so we can have say the length of the strings can be stored in R1 and R2. So, these are and the problem also says that the subprograms should use different register banks. So, compared to the original register bank, whatever the main program will use, this program, the subprograms, they should use different register bank. Now, for doing that, we have to change that PSW bank selection bits, okay, register bank selection bits, and accordingly it is it will be using different banks. So, the strings are null terminated, that is if I have got say S1 equal to say the string ABC, then from location 6000 onwards the string is stored. So, if this is my memory, so from 6000 onwards, so this is 6000 say. So, here I have got the character A, then the character B, then the character C. So, these are the corresponding ASCII codes are stored there, and then we have got the null character 0. Okay. So, this is 0, and then after that S2 starts. So, it is not, the string lengths are not mentioned. So, you cannot set the other pointer directly. So, in this particular case the next string will start at 6004, but it is the length is not specified. So, you cannot set it directly. So, from the program we have to locate for this end of string, and accordingly we have to set the beginning of the next string. And once we are done, we have set one pointer, somehow we have attached one pointer here and one pointer here, then we can start doing the comparison. Okay. So, the next string may be say CD. So, it is C, this is D, and this character should be 0. So, that is the end of the string character is there. Okay. So, this way the strings are stored. So, we need to write down the program which will do this thing, do this string comparison and length calculation. So, you see how to do this thing. So, first what we do, first we take this, first we change that register bank. Suppose we do like say set bit PSW dot 3. So, it changes one of, it sets one of those register bank bits, and it is assumed that by this the register bank is modified. Okay. So, of course, there is an assumption that PSW dot 3 this bit was 0 previously. So, the main program was using the register bank 00, and so so that is that assumption is there, but otherwise. So, you can manipulate this part here, so that the appropriate register bank is selected. Then in so we have to get this 6000 address. So, we save in the register R3 the number 60 hex, and in register R4 we save the number 00 hex, that will constitute. So, these values will be needed to be moved to this DPTR register for doing the comparison and all, getting the values from external memory. So, DPTR will be used. So, we will do that later. So, then after that we give a call to a call compare. So, this a call compare statement, so it will give a call to the subprogram compare. Okay. So, we will see that compare program. After that, suppose this compare program, so it has put in R0 some value, that is the result of this comparison. Okay. So, then we clear PSW dot 3, so that we go back to the previous register bank, and then move R0 comma 08. Okay. So, move R0 comma 08, because the result should be in R0, and by setting this PSW 3 bit 1. So, it is expected that it is going to register bank, it is going to register bank 1. So, the basic program is working with register bank 0, and if it is the sub programs, they will be working with register bank 1. So, register bank 1 starts with address 8. So, this compare routine, so it has set that return value in R0, but that is in the actually the register bank 1's R0, and so that as a result that is the memory location 08. So, from after clearing this bit, so if you make this move R0 comma 08, so from memory location 08 the content will come to the register 0 of the current bank. Okay. So, that is actually, if the current bank is 0, then it is actually the memory location 0. So, this is done. So, this is the end of this. So, after compare, the result is stored in R0, that part will be finished by this. After this, I have to compute the length of the string. So, again I do the same thing. First of all, I change that register bank to 1. So, set b PSW dot 3. Okay. Setting the now we again set this R3 and R4 registers to contain the lengths of the start address of the two strings R3 and R4, R4 00 hex and R3 60 hex, and then we call a subroutine a call length. This length routine, so it will return the length of the two strings in the registers R1 and R2 of the bank 1. Okay. So, from there I need to put get them back onto R1 and R2 of the current register bank. So, for that purpose what I do, clear this PSW dot 3 bit. Okay. So, we clear this PSW dot 3, so that we come back to the previous register bank 0, and then write like say move R1 comma 09, so that from this register R1 of bank 1 the value will come to the register 1 of the current bank or the original bank 0. So, that is the length of first string, and then a move R2 comma 10. So, this will take the length of the second string available at register 2 of bank 1 to register 2 of bank 0. So, that is the end of the program. Now, I have to write down the routine for this comparison and this length. So, these two routines are to be written. Okay. So, first we try to write the routine for compare. So, the compare routine will be something like this. So, compare routine will be like this. First we have to get, so R3 and R4 they are actually pointing to the memory location 6000. So, if this is your memory location and this is the address 6000, then that R3 R4 pair is pointing to this one, R3 R4 pair is pointing to this. So, this R3 R4 values they should be moved to DPL and DPH registers, so that I can use the DPTR for accessing individual memory locations. So, we move DPH R3, so that 60 comes to DPH, and move DPL R4. Okay. So, we have got this 6000 in the DPTR register, and we also save this R3 and R4 in two registers R5 and R6 for otherwise they may be required. So, move R5 comma R3 and move R6 comma R4. So, these two statements, this is just to keep a copy, this is just a keep a copy of this R3 R4 pair, because this pair will be modified as we proceed. Then we have to get, now what the next job that I have to do is the, say I have got the string like this A, B, C, etc. The last character of the first string is 0, and after that the second string will start from this point onward. So, first job is to find the location of the second string, find from which point it will start, I have to find that. So, for that I need to search out this 0, where is this 0, that has to be searched out. No, so that will be the, so we will be doing that. So, what we do? We do it like this, we use move x a comma @DPTR. So, as a result the first location content will be coming to the A register, and then we do a CJNE compare jump not equal A comma hash 0 comma some label L1. So, if the value is non-zero, if the value that I have got here is non-zero, then that is not the end of the first string, fine. So, we are looking for this end of string. So, the character that we have now is not the end of the first string. So, we jump to level L1, compare jump not equal to L1. Then we put here 1, but if they are same, if the two characters, if we are accessing say this particular location, then what will happen, this A register content will become equal to 0, and by that time our pointer has advanced and we have come to the location where which is the end of the first string, fine. So, that way, so if they are same, then we jump to the level L2, that means which will actually we will see that it corresponds to the position where we have come to the end of first string. Okay. Then in L1, so in L1 what I have to do is, so the character is not the end of string character. So, I need to increment the dptr value. So, inc dptr, the dptr value is incremented, then this dptr is saved again in R3 and R4. So, move R3 comma dph and move R4 comma dpl. So, dph and dpl values are saved in R3 and R4. Then what we do? Then we have to then we have to go for next one. So, this R3 and R4 we have saved the value. Now, this R5 and R6. So, we had the previous value of this dptr. So, this SJMP L2. So, this L2 will come here. So, L2 is somewhere here. Okay. So, this is our L2. In L2, that means we have come to the second string. Okay. So, then I need to start doing the comparison. So, this way. So, that is, so see from this point SJMP L2. So, when this is matching, so we are coming to this point. So, from this point onwards, so I can if they are same, it is the end of the first string. So, I can start doing the comparison. So, how do I do it? Like I first get this, so this dptr has come to the end. So, dptr has to be taken back to the first position. So, we first do move dph comma R5 and move dpl comma R6. So, that way in R5 R6 pair we had stored the previous dph dpl values. So, they are moved, they are from the R5 and R6, those values are moved. Then we do like move a comma @dptr. So, from dptr, so we are getting the next value. So, dptr, so we have come back to this point. So, we have got the character again here. Then we save this character that we have read for the from the first string into the B register. So, move B comma A, this will save this value that we have read into the B register. Then we increment dptr, and save dptr. So, whenever we increment, so we save the dptr in R5 R6 pair, so that we can load it later. Say this is dph and move R6 comma dpl. Okay. So, that is saved there. Now, so after this is done, so we have saved this dpl dph. Now, I have to get this the first character of the next string, and those DPH DPL values are stored in the these R3 and R4 registers in these two statements. So, those DPH DPL values will be accessed. So, I am writing from this point here. So, move DPH comma R3, move DPL comma R4, okay. Then move X A comma at the rate DPTR, okay, move A at the rate DPTR, then INC. So, we will increment. So, that will go to the next character. So, whenever you have accessed the, so we have read the first character from the second string. So, the pointer should advance. So, this pointer is advanced and the values are saved in R3 R4 again. So, move this R3 comma DPH and move R4 comma DPL, they are saved there. And then what we do? We do CJNE compare jump on not equal. So, now this A and B, so those two register values will be compared and it will be going to L4. Now, if it is now if they are not same, then I am going to L4. If they are same, then another condition I need to check, maybe this character is A. So, that is also a match. So, for the entire string matched, the last character that will have, so that will also have a 0 there. So, this 0 should match with this 0. Okay. So, these two zeros should match. So, for doing that, what I do? So, if it is they are not equal, I am jumping to L4, otherwise I am doing an add of AB, So, A and B are added and then we check whether the result is 0 or not. So, CJNE A hash 0 comma L5, okay. And then move. So, if they are equal, then I will come to this point, move R0 comma hash 1 and move R0 comma hash 1 and return from there. And this L5, this L4 will be, L4 is actually this point, move R0 comma hash 0. So, this is the point L4, okay. This is the point L4 and this is CJNE, the characters are same, but they are not 0. So, this is L5. So, this should better be L2, that will do it correct, okay, because if they are not same, I am jumping from here to here. So, this level should be L2. So, this one I should better make it L2, then the program will be correct, because now I have got the next character. So, again I am going to compare the next character. So, what has happened is the first two characters have matched. So, if it is coming from here, then the first two characters have matched. So, now I am getting the next character. So, this move X will get me the next character of first string, this move X will get me the next character of the second string, and then I am doing a comparison of them in this CJNE instruction. Okay. So, in the CJNE instruction, so I am doing a comparison, and if they are not, if the characters are same, okay, it will come here and it will come to this. If the characters are not same, then it will come to L4. So, this R0 becoming 1 means the number is the strings are not same. If R0 becomes 1, then the strings are not same. If the strings are same, if the characters are same, then I am checking whether I have reached the end of the string or not. So, that way, by doing this program, so I can do a substring check part. Okay. Now, if you want to do so that is there, that is setting 0, and this L4 is So, this is L4. So, CJNE A has 0. So, if that it is 0, then it is coming to so it is otherwise it is not same. So, in that case it will be returning if the characters are not same, then it will be returning 0. Okay. So, how to do that? CJNE 0 L2. So, this can be. So, after this I should have something like this, move R0 comma hash 0 if the strings are not same. So, this is if the characters are same, then it is adding here, and then I am checking end of string. If they are not same, if they are not same, this rate I am sorry. Yeah, so there should be one SJMP here, some L5, and in L5 I should have the rate, the return part. Okay. So, that will do this thing correctly. Now, regarding the length part, so you can the length calculation part. So, you can do it like this. The length part is simple. So, we can do like move dph comma R3, from R3 we get dph, move dpl comma R4, from R4 we get dpl, then move R1 comma hash 0, and then we say move x at the a comma at the rate dptr, move x a comma at the rate dptr, then compare jump on not equal this a hash 0 say L7. So, it is comparing whether we have reached the end of the string or not. SJMP L8, in L7 we increment R1, then INC DPTR, will increment the DPTR register, and then we check whether then SJMP L6, where L6 is this point. Okay. So, here it is so this way I can check I can get the length of the first string. Okay. So, till it is coming to this 0. So, compare jump on not equal a has 0 L7. So, it will be incrementing, and this is the point L8. Okay. So, this way I can get the length of the first string calculated in R1 register. So, you can repeat this procedure the similar code starting from L7 L8 for the length of the second string in register R2. So, you can just replace this R1 by R2 and you can get the next strings length calculated.